for the next session, we have Dr. Kader sir from the Kader sir, are you there?
Yes, I am here, sir. Are you hearing me?
Yes, sir.
Hello.
Yes, sir. So for the next session, we
Hello,
have
sir. Are you hearing me?
yes, sir. Dr. Kader sir, he is assistant professor,
Okay.
Department of Plant Biology and Biotechnology, Presidency College, that is Autonomous College in Chennai. I would like to give a brief introduction of him. He has several best paper presentation awards to his credit. He has visited to countries such as Indonesia, Malaysia for presenting his research findings. He has at least 13 international and 20 papers published in conferences. He has written a book on a topic, a textbook of medicinal botany. He discovered 3 new plant species, and he has guided at least 5 MPhil and PhD students. So I would like to request Dr. Kader sir to resume his lecture. Dr. Kader sir.
Okay. Thank you, Dr. Raghavendra, sir. Good evening to all of you. I am going to speak about the measures of central tendency and dispersion. Okay. I am going to talk about measures of central tendency and dispersion. So in research, we collect data of large quantities, and after collection of the data, we want to get some useful information from the collected data depending on the interest of the researcher. And for that, we have to study and process the collected data. There are several statistical methods available to analyze and interpret the collected data. And the measures of central tendency and dispersion are the simplest statistical tools among them applied to analyze the data. Measures of central tendency is nothing but the concentration of central values in central part of the data set. In other words, measures of central tendency in layman language, we can say it is simply the average of the values. And these measures of central tendency have been defined in several ways. However, the 3 most common measures of central tendency are arithmetic mean, median, and mode. So these are the 3 central tendency measures, and the data after collection we have to process, and sometimes the data are ungrouped or they are grouped, and for finding out the central tendency measures, and for grouped data we have to use some statistical formula, or if the data is ungrouped, then we can find the measures of central tendency without using the formula. However, though the data are ungrouped, but with the frequency, then we have to use the statistical formula to find out the mean and median. The first one, arithmetic mean. Arithmetic mean is nothing but the average value in a numerical data set. And this arithmetic mean most commonly used to measure for quantitative characters. So the data characters, the variables may be qualitative or quantitative. And for quantitative variables, mostly the arithmetic mean is commonly used. And usually we collect the samples from the population, and the mean found out using these samples is called the sample mean. Or if you directly or the entire the individuals of the population, then it becomes known as the population mean. And the sample mean can be denoted with the x bar and the population mean mu. But for finding out the mean of both the sample and the population, the formula is the same. And the arithmetic mean is based on all the observations of the collected data. And this arithmetic mean is affected by extreme data values and sampling fluctuations. And as I said, if the data is ungrouped, we can find the arithmetic mean without using the formula. But for ungrouped data with the frequency, then the arithmetic mean can be calculated by using the formula. And so this is the formula. As I said, x bar is the mean. This is sigma. The x number of values in the data set. This n is equal to the total number of observations. So with the help of this formula or the symbol, or we can find the arithmetic mean for the ungrouped data. So with the example, we can easily understand. So this is the formula. That means mean sigma x is nothing but the sum of all the observations and divided by total number of observations. Let us see the example. The Crotalaria species pods are counted for their number of seeds, and in the experiment, the 10 number of data were collected. Then using this data, we have to find the mean. So what we have to do is simply sum up all these 10 observations, nothing but the sigma x divided by 10. So this is the result we got. Note the mean. So 4 plus 7 plus 8 plus 7 plus 10 plus 11 plus 9 plus 9 plus 9 divided by 10. So we got the mean is equal to 74 divided by 10. So 7.4 is the mean. If the second example, this is the grouped data. Here we have the age interval class and the frequency. So using this data, we can find the mean with the help of this formula. Mean is equal to sigma fx divided by sigma f. So for calculation, what we have to do is, first we have to draw a new table with 4 columns. In the question, we have 3 columns, but for computation, we have to first make 4 columns. And in the second step, we have to fill the data in the new table, except the 4th column. And in the 4th column, we have to multiply f and x frequency and the data and fill in the 4th column. And in the next step, we sum up the fx value, and then we have to find sum of the f values, then apply the formula. Then we will get the total fx is the 867 divided by total frequency 114. So average, the mean we got is using this formula is 7.61. So like that, our interests vary depending on the researcher's interest. So basically, I am a plant biologist and life scientist. So I give here the examples from the life science part. So the other examples one can be interested to find out the growth performance of a particular plant species. The forestry people may be interested, or the forest department people may be interested. Second example is the effect of pre-sowing treatment on seed germination percentage of particular species. The agricultural field people, botany people, or the other forestry, etc., the forest department people, all those who are handling the seeds may be interested in finding the germination percentage of any important species. Or one can interest to find out the crop yield in the agricultural field of a particular species. For example, rice, or wheat, or banana, or whatever it may be. So what we have to do is for these experiments or for this example, you might be aware of that statistical or the experiment must be carried out with minimum 3 replications, usually 4. And the second condition is the sampling should be random, or if possible, collect all the individuals from the area for sample collection. So when we collect as much as samples or the entire individuals in a population, we will get the accurate mean value. As I said earlier, the mean value is affected by extreme data values and sampling fluctuations. So in order to avoid that, we have to collect as much as possible data, measure individual, maybe here if you take the leaf length or the petiole length or the lamina diameter or whatever it may be. The second one is the median. The median is the another measure of central tendency. It is simply nothing but the middle value in a numerical data set. Here also, sometimes the data set contains odd number or even number. If it is odd number, then it is very easy to find out the median, because the odd number is the middle number in the data set. Or in the if it is an even number, then it is the median or the middle numbers of another two numbers. And when to find out the middle or median of the even number data, we have to add these two middle numbers and divide by 2. So for processing or computation of this median, what we have to do is, first we have to arrange the data either in ascending order or in descending order as given here. I used the same example, but for so the first step is you have to arrange the data either in ascending or in descending order. So this is the ascending order, this is the descending order. Then we find out the middle value. Then third step, here our data contains only the 10 values. So naturally our data is the another even number. So we have to select the two middle values as here. So this is an ascending order, this is a descending order. Anyway, if the data set is arranged ascendingly, we will get 8 and 9 values as the middle two values, or if it is descending, we are getting 9 and 8 in the middle values. Whatever may be the case, we have to, in the next step, we have to sum these values and then divide by 2, then we will get the median. So 8 plus 9 by 2 in the ascending case, 9 plus 2 by in the descending case, whatever may be the case, in both the case, the total sum is the 17 divided by 2, we get the median is 8.5. As I said, if the data is grouped, we have to use the formula for median, and so using this formula we can find, but this condition does not arise in majority of the cases, so we can leave this one. And this also the grouped data, the forward of the frequency, so this we can leave. So we are not going to normally use this formula for finding the median. And the third one is the mode. The mode is nothing but the most frequently occurring value in a numerical data set. In the data set, there may be a single mode or several modes, and these modes are affected by sampling fluctuations, but not affected by extreme data values. And another one drawback is this mode is not based on all the observations, unlike the arithmetic mean and mode. So using the same example, the data on the number of seeds per pod of Crotalaria species is given. Find out the mode. So here also, first what we have to arrange the data either in ascending order or in descending order like this, and find out the frequently found value. In the data set, we see the 9 values in 3 times. Hence, the mode is simply the 9. And there is a relationship exists between mean, median, and mode. So this is the graph of the normal distribution. If the graph symmetry, the curve is symmetrical, then the value of mean, median, and mode will be equal. If the frequency distribution is positively skewed on one side, that's the skew, then positively skewed, then the mean is always greater than the median, and the median is always greater than the mode. If the frequency distribution graph is negatively skewed, then mean is always lesser than the median, and the median is always lesser than the mode. That means this, if the graph is positively or negatively skewed, then there are some problems in the data collection. And if we have the moderately skewed distribution, there exists a relationship between mean, median, and mode, and this relationship can be known as empirical relationship. Empirical relationship. This is nothing but the difference between mean and mode is almost equal to the 3 times difference between the mean and median. So this is the relationship empirical formula between the 3 measures of central tendency. If the graph is moderately skewed. Now let us see the relationship between mean, median, and mode of the selected example. Here also again I am giving the same example, but using this example we got mean 7.4, median 8.5, mode 9. But when we visualize the data, the raw data, we see we have the 2 extreme values. So the minimum, the lowest value is the 4, maximum value or the highest value is the 11. So as I said earlier, mean is affected by extreme data value. Hence the mean is another. The mean is lesser than the median, and median is lesser than the mode. Since in the example mean is lesser than the median and the median is lesser than the mode, our example is negatively skewed frequency graph. That's our example has a negatively skewed frequency distribution. And another category measures the measures of dispersion. So measures of dispersion is nothing but how much the other values in the data set deviates from the average value. Mean, median, mode, find the average value in a data set or in a normal distribution or probability distribution data. And this dispersion helps to find out or to evaluate how other values in the data set deviates from the average value. So in the example, we got the mean 7.5, median 8.5, and mode 9. So in order to find, because there are some differences between the three values, mean, median, and mode, so we can use the dispersion unit like the range, mean deviation, standard deviation, variation for the ungrouped data. For grouped data, we have another the range, standard deviation, variance, and coefficient of variation and coefficient of skewness. So it is very simple. All these have except the range, mean deviation, standard deviation, variation, coefficient of variation, and Pearson coefficient of skewness have formula, and we fit the corresponding values in that formula. We can easily find out the result. So as I said earlier, in our example, the highest value is the 11, the lowest value is the 4. So the range in our example, that means the number of seeds per Crotalaria species spot range from another in a descending order 11 to another 4. The mean deviation, we can find that the mean deviation is equal to the sum of x values total, how much, divided by mean divided by the number of observations. We can get the mean deviation. Simply we know the x values, we know the mean values, we know the number of observations. Only thing, we have to calculate the sum value and fit it into the formula. Naturally we can get the result easily. Like that, the standard deviation also, we know all this in number, the degrees of freedom, number of observations minus 1. This is the, we have to square the x value. This is after that only. Only thing here is we have to get the square root of the values. We will get the standard deviation. And to find out the variance, another we remove the square root, then we will get the, we know all, we know the data, we know the values of this. So we can easily get, we can try with the current example. And for the grouped data also, here the range is somewhat little different, that we have to take the upper class boundary of the last class and to the lower class boundary of the first class. We can, in the grouped data, we have, though I have not given here, but we can easily found out from the table or the grouped data. And for that, here also for the grouped data, the standard deviation and variance formulas are little different, but we have the data in the table, the frequency and the x we have to calculate, and simply we have to put it into the formula, we get the result. And this is the coefficient of variation, nothing but standard deviation divided by mean into 100, simple formula. So thank you. Any other questions there? Hello?
Yes. participants, if you have any question, please.
राघवेंद्र सर,
हाँ मैम,
tell me, madam.
सर कोई क्वेश्चन नहीं है सर यहाँ पर अभी।
No question. Thank you, madam.
so I would like to call Kranti madam for formal vote of thanks. Dr. Kranti ma'am.
थैंक यू सर। राघवेंद्र सर
Thank
थैंक
you.
यू। मेरी आवाज आ रही है? ओके, इट्स
एक
माय
मिनट
ग्रेट
मैम,
प्लेजर।
एक मिनट जरा सा, एक पुष्पा टॉपनो है जिन्होंने क्वेश्चन पूछा है, इफ वी वांट टू स्टडी ऑन प्लांट्स लाइक फ्रेश वाटर एल्गी, हाउ कैन बी फिक्स पॉपुलेशन?
I am not clear, sir. Once more, sir. I am not clear. Please, once more.
CH was asked the question, if we want to study on plants like fresh water algae, how can we fix population?
So in the freshwater is that we have to select the area. I mean, it is difficult to the population. Maybe the pond may be small or larger in size, but there we have to fix the quantity. About say, for example, whether in 100 ml or in 500 ml or in 1 liter. So that we have to fix the population. In 100 ml water, this much particular algal species is found. So when we have to find 500 or in 1 liter, we have to multiply simply the values we got in the 100 ml. If you take this 200 ml sample, then you get some different algal species, freshwater species, and how many numbers you get in within that 200 ml, then we have to multiply for the entire area. I mean, it is very difficult to find out, but we can assume that maybe some 1 gallon of water or like that only. Simply we have to multiply the result.
Okay, thank you, sir. Now, ma'am, please continue.
जी। It's my great pleasure to thank you, sir. Abdul Kader, sir, your explanation was very clear, and you clearly explained the all methods of central tendency. Sir, I, Dr. Kranti Singh, with our organizing committee and our principal, Dr. Anwala Tiwari, thank you for your explanation and lecture. Nice lecture.
Thank you,
sir.
madam. Thank you, madam. And one more thing I would like to say, madam. I place my obligations to Dr. Raghavendra sir for giving me this opportunity to present this before this gathering. Thank you, sir.
Okay.
Thank you, sir. Thank you very much for joining us.
Thank you, sir.
Thank you.
Over to Poonam ma'am.
Today all sessions are finished, and we will meet tomorrow again on the same time, 11 a.m. Okay, have a nice day.
This conference will now be recorded.